So I have some
Sorry,
notes
Beast.
here. I have some notes here that I made from the when I was doing this research. So just let me read to you a little something from my notes. So like I've been digging pretty deep, and I've honestly been amazed by like how analogous the comparisons are between fluid dynamics and relativistic phenomena and other things, especially like in like relativistic quantum chemistry and electrodynamics. Things like the vorticity equations and the Prandtl-Glauert equations and Thomas precession. You have the Korteweg de Vries, the KdV equations, and relativistic mass increase, energy inertia increase. You have wave wakes and Larmor radiation. You have the Magnus effect and the Lorentz force, which are like mirrors of each other. Even the equations are. And then you have soliton compression and the Lorentz contraction. And the mathematics of these are identical in almost every case. So
You sharing
you
your
can
screen?
no, I'm just
Oh,
I'm just talking. So you can build a bridge. Like if you look at the Prandtl-Glauert factor, you can build a bridge from that directly to the Lorentz factor. They're the same factor when you look at the terms in the equation. And you can show, like I said before, just a second ago, that the Prandtl-Glauert relation directly results in the Thomas precession equation if you just get rid of the leading one term in the Taylor series of the Prandtl-Glauert. And the leading one comes from static pressure on a foreign object in the medium. So since the soliton is made of the medium, it doesn't receive the static pressure, so you drop the one, and then it becomes identical to the Taylor or Thomas precession's Taylor series. And then the Korteweg de Vries equation, it describes the behavior of nonlinear, dispersive, but non-dissipative waves, which include solitons. So regular waves, if you think about it just like a regular wave, these waves get torn apart over time by dispersion, which is the wave spreading, and nonlinearity, which is the wave steepening. But solitons strike a perfect balance between these two, so they create a localized bundle of wave energy that moves as a single unit. And the KdV equation, Korteweg de Vries, KdV, the KdV equation shows that a soliton's amplitude is directly linked to its velocity. So the more energy it has, the narrower and faster it becomes. And that mimics the Lorentz contraction, right? And the relativistic mass increase that you see in electrons. When you take the vorticity equations from fluid dynamics and you apply the vorticity to a KdV style soliton, because the soliton is not a foreign object, it's made of the medium, right? And it doesn't have a solid core, then the rotation is entirely applied to the phase of the medium. So that precession that you see in Thomas precession, right? That 1/2 factor, which is identical to the vorticity equation and identical to Thomas precession at speeds much less than c, that appears naturally because the rotation of the soliton's envelope has to be slower. It has to lag. It has to lag behind the rotation of its internal phase in order to maintain the stability of the soliton. So the outside's rotation has to lag a little bit for it to stay stable. Now, as it moves, like translates, of course, moves through the ether, the medium. Larmor, his formula describes how it radiates power out. So when that electron accelerates, it is not able to instantly perfectly adjust its structure. There's a lag. It doesn't respond instantaneously, right? There's properties of the medium. It has stiffness and all these different things which determine how quickly it responds. So since it can't respond instantly, there's a small lag. That lag in its response results in it shedding energy, which we call that Larmor radiation in classical electrodynamics. And in fluid dynamics, it's called a wake, as I said. But in a fluid medium, when this soliton accelerates, what actually happens is it creates a pressure imbalance between the front and the back. So as it speeds up, the leading edge, the front of it, compresses the medium. That increases the local pressure at the front. And then the trailing edge leaves a low pressure zone behind it, okay? So there's a pressure differential. And if the acceleration is high enough, then the tail cannot keep up with the head, and a piece of the energy gets pinched off of the back, and it propagates out as a secondary wave, as a photon. And there's an equation that describes it, the Larmor formula. But just like in that formula, fluid wave radiation also scales with the square of acceleration, because the slope of the pressure gradient in that fluid, which is proportional to the force, has to be squared to calculate the energy flux. So that's you can't see the equation, so that might not matter much right now, but that's how it works out. And then there's a 2/3 factor, which comes from the geometric relation to the surface area of a sphere, because the radiation, so the energy that radiates spreads in all directions. It's like a spherical shape that it spreads out in. Every direction equals sphere. So when you integrate the energy flux of that, of a spherical distribution shedding in every direction, you see that only a fraction of the work done by acceleration escapes as a wake, which is, turns into a wave that radiates as a photon. The rest of that energy stays present as added inertia, reactive energy. It stays present in the soliton, because it's the energy of the medium pushing back, right? A little bit of it radiates out. There's a photon sheds away, and the rest of it stays in the soliton and gets picked up as a mass increase. Now, as v gets close to c, right, it speeds close to the speed of light. When we get to relativistic speeds, they say, the radiation power scales up exponentially. So the closer you get to c, the more energy sheds away. That's the reason that you need infinite energy to accelerate an electron to the speed of light. Because the closer to the speed of light you get, the more energy you end up radiating away instead of adding to the velocity. So that makes intuitive sense, but also because how could you possibly
It does,
accelerate?
yeah, I agree.
How could you possibly accelerate a wave bundle of the medium? So like there's a bundle of medium, right? How could you get a wave bundle of medium to move faster than the wave speed limit for a medium? You couldn't. It
Right.
doesn't even make sense.
It'd be
So,
crazy if it turned out the whole time that there was something known like as an ether. After all
and then
these years of them saying that they wasn't.
it doesn't stop there, dude. Well, it's even crazier when you think about the Lorentz force. So the Lorentz force, right? It's the force experienced by a charge, an electron moving through a magnetic field, right? F equals QV cross B. Okay. If you treat the magnetic field as the vorticity of the ether, right? Because when you actually look at Maxwell's equations, the definition of a B field, B equals the curl of A. So B just describes the rotation of the A field. So if the A field is the ether, and you just think and you say, okay, so B describes the vorticity of the ether, then the Lorentz force becomes mathematically identical to the Magnus effect. Okay, or also sometimes it's referred to under a Kuta-Joukowski lift, but it's the lift force experienced by something moving through a rotating field. So if you guys know what the Magnus effect is, it's how, like, if I take some kind of
The
sphere.
Coriolis.
Well, if I take
Essentially.
let me say I take like a tennis ball or something, and I spin the tennis ball really fast, it will actually create lift if it moves through an air current, because um, basically you have the rotation of the tennis ball and it's interacting with the rotating field of the air that it's moving through. And as these two terms add or subtract, they interact with each other, they cross one another, it actually creates lift. It's mathematically identical because Lorentz force F equals QV cross B. Magnus effect is F equals rho V cross gamma. And so this explains the deflection of electrons moving through a magnetic field, because they experience lift due to the differential pressure between the two vortex fields, the vortex of the spinning soliton and the vortex of the curling magnetic field. On one side of the soliton, the spin velocity adds to the flow, and on the other side it subtracts, and then you apply Bernoulli's principle, because Bernoulli's principle says the side with higher velocity has lower pressure. So there's a pressure gradient that creates a net force, and it acts perpendicular to both the velocity and the axis of rotation. That explains why the force is perpendicular in the Lorentz force. That ties everything back together perfectly. It goes back to the 1/2 ratio of precession. Just like how we see the force in the Magnus effect depends on the circulation term gamma, we see the same fluid mechanics applied to precession. Since the effective rotation omega is half the vorticity in the vorticity equation, then the lift generated by a wave packet, an electron, is scaled by the same 1/2 factor as in Thomas precession. So the Taylor series handles all those terms all the way past the 1/2 as the velocity increases, and it causes compression of the ether, and that compression responds, it adds inertia, requires more energy to move faster. It also, the last thing it explains spin 1/2. So it's known in physics that electrons have what's called spin 1/2. It's a fancy term. It basically says that instead of taking one
Heard of
full
spin, but I've never heard spin 1/2.
yeah, instead of it taking one full 360-degree rotation for an electron to turn around back to its original orientation, it takes two of them. It takes a 720-degree rotation. It takes two full turns. Now that seems counterintuitive, and they just explain it like abstractly, right? But what if you apply this to fluids? There's also a perfect analogy. So in fluids, this exact spin 1/2 happens in Mobius-like flows. So you can watch animations of like a sphere that has a Mobius strip attached. Look up at what a Mobius strip is.
Yeah, I know it
But
is.
they require 720 degrees of rotation to return to the original orientation. And I can actually copy a. I'll put a link. I'll put a real quick. I'll put a link to the
Yeah,
video.
it's just a loop with like a
Bro,
belt, but you invert it.
bro, you
One.
ever see the
There
you
you
ever see
go.
the Mobius? You ever see the Mobius strip thing? It can just stay in flight constantly as long as you keep like an angled like board behind it. You ever see the
Yeah.
guy demonstrate that?
Check the video I just put in the chat. It shows a visualization that explains it perfectly. But if you look at like this in fluids, this spin 1/2 property happens in Mobius-like flows. And one example of a Mobius flow is a toroidal vortice, or toroidal vortex, because there's a coupling between the internal flow, which is poloidal, and the external flow, which is toroidal, and that gives you a vortex soliton that's effectively a tiny gyroscope that's made out of the medium it's traveling through. So I believe that electrons are actually solitons that are like toroidal vortex solitons that act like little tiny gyroscopes, and then you piece all of these together and into bigger and bigger structures, and you get atoms and molecules and so on and so forth. But using these fluid dynamics relations, you can use classical mechanics to model the effects on the electron as it compresses the ether and it gains inertia and it radiates energy out as it processes, as it spins, as it gets deflected in a magnetic field like a vortex field. It's to me, bro, it's honestly amazing to see like how fluid dynamics, just you apply fluid dynamics and it's perfectly analogous and it accurately describes all these behaviors that are typically attributed to like the geometry of empty space-time.
And you don't have to have all that weird stuff like saying something's a particle and a wave at the same time, and
Correct.
you know what I mean. Like that's what I was thinking when I saw, especially after watching that Veritasium video. It made more sense in my head to say that it works like they were saying, you know, like something on a background medium. Well, that background medium would then be the ether.
Yeah, and it
That
explains time dilation too, like the whole clock pair, the clocks changing on atomic clocks, because the reason that the clock slows down is because since it's moving through the medium and the medium's pushing back on it, it compresses that soliton a little bit, and it the soliton now requires a little bit more energy in order to oscillate, but it only has as much energy as it has, so that extra stiffness essentially that it experiences causes the oscillation to slow down, and then your
yeah,
clock ticks slower.
it can only travel as fast as it can move through that medium, and that medium only let it go so fast, so it won't maintain the momentum of whatever it left from, even if that had speed, because it can only travel at a certain speed through that background medium.
Yeah, so this gives a not only an intuitive but a physical explanation for things like Thomas precession, for example, because it actually gives a real source for the torque on an electron. Like when an electron precesses as it orbits, they don't have an explanation other than to say space time, but they don't have a source for torque. But there's something known as the Mansour-Pore paradox, and it explains that perfectly because now you have a source for the torque. Because in order to explain the Mansour-Pore paradox, you have to have this paradoxical concept of hidden momentum in order to explain it, and that's just nonsense. And so, like, it's just like, dude, I started digging in this stuff like not that long ago, a couple weeks ago, and yeah, it's
Bro,
literally every fluid dynamical equation that I look up in here applied. Like some of them are literally built for solitons, like the KdV, and the parental glower can be applied to them if you just drop the static term, and then it literally perfectly matches like relativistic or quantum electrodynamics.
Piezo, only you could casually drop 6 to 7 new terms in a conversation and it be completely relevant to the same topic.
No worries, bro.
That was insane. What the fuck paradox did you say? What's it called?
Mansour-Pore paradox.
Okay. Someone should
Basically, how
timestamp this in the recording so they can go back and like actually listen to what he's talking about.
yeah, here I'll just tag you, Biastically. I'll tag you, and then I'll just give you a list of terms that came up here. 1 second.
But yeah, Cole. There's a lot less incongruent thinking when you have a background medium.
Yeah, I agree. It's just funny though that, things like that would then represent themselves as like electrons or protons or photons or neutrons. Or even now they got quarks and everything that makes up this stuff. But the things we're talking about are the smallest things that can possibly exist. That's what would make up the background medium. Like, in my in my opinion, it would be like the base level of the simulation.
You could say that, I guess.
I had to say that.
Or light.
I feel like things just get smaller and smaller, and I just wonder if there even is a thing at the bottom, or if we're not just part of. Like, what if our entire universe made up a quark in a larger atom? And things just, there was no end to smallness and largeness. It just went on forever. So we could literally be like a quark inside of a proton, inside of in the body of an atom, and something that makes up something material far bigger. And we're just, you know what I mean? But to us, we see it as our entire universe, but it could be just something very tiny in the next universe up, or the next whatever's going on, bigger. Because if the universe is something that just pops out of like whatever's it came from, then it would have to be like, there would have to be something that is doing it. So there'd have to be some type of other whatever, wherever reality or whatever you want to call it, that these
Oh, nice. Look at
universes seem
Piezo
to pop
tagged me
out
in.
of.
Grab
You know what I'm
that too,
saying?
Cole.
What's it?
Look on the chat.
Get back here.
I'll tag you to reply so you can get it too.
I posted Witset's logical questions about Mickelson-Morley for whoever was saying that all it did was debunk the ether. They should answer that.
Oh, that
I
was
was gonna
NASA's
ask
show.
why Cole sounds like a flat earther.
Yeah, but real quick, let me take a quick survey for anybody that was listening. Was the whole medium fluid dynamic explanation of quantum electrodynamics
You're just a
intuitive and
liar.
coherent?
No,
Was that
you're just a
coherent?
liar. You're a
I
liar.
found
The
it
ether's been
coherent.
disproved. You're a liar. You're a liar. Yeah, do you see how we
Well,
would
it's a little
never have
bit.
gotten to that conversation
That was
if I
Cole.
didn't mute that guy?
You don't know
Yeah.
what the papers are saying, reference frames, refraction.
Yeah, that
That's
conversation
really
would have
about it.
never existed
That's
if I just
it's
let
it.
that
It's
guy
over.
continue. Yeah.
I just
Classical
like that
dynamics is the
idea.
true physics, bro.
I just like that idea, the way that we was talking about.
Oh,
I like the way that works.
well, you were talking
Well,
about simulation, right? Like you
No,
heard the
no,
idea
no.
of
I'm talking about before that. I just mentioned simulation. Be silly.
no,
I'm talking
no. I
about
was gonna
before
add on
that.
to it. No, I was just gonna add on to
Oh,
so the image of God, like we were made in the image of God. Well, if you think about like the if we're in a torus field, right? Like in terms of the, at the north, there's actually that's actually a vortex. There's actually a vortex there. If there is an ether wind or ether drag, if you will, right? That follows sidereal rotation. And then you can actually look at like how our bodies operate, and it's basically like a toroidal. Like if you were to spin your
flower
body,
life
right?
pattern.
Yeah, the flower of life pattern, exactly. Like, kind of makes sense.
It's also how the planets move. It's the orbital path of the ISS. It's a lot of things.
Yep.
You just take the top-down view over the North Pole. It's what everything looks like. But
Exactly.
yeah, dude. When I say classical mechanics, I like to give this disclaimer before I get strawmanned by people. The classical mechanics is disproven by relativity. What I mean by classical mechanics is that everything is able to be explained mechanistically, and everything follows the principle of local action. That's all classical mechanics was ever intended to mean.
Local action meaning scalable, right?
No. But the principle of local action meaning that entities only act upon one another where they are located.
Yeah. You don't have quantum mechanics is crazy.
There's no such
In
thing
a
as
lot of
action at a
ways.
distance.
Right, because hence why if there's a medium between the thing that's distant,
Right.
it's technically local.
Right. Correct. Yeah. The medium is local there and there at both points, and you touch it here, and it pushes the influence through the medium and touches it there. Right.
Got it.
If I want to push my desk, I either have to touch my desk or fan the air really, really hard so the air blows across the desk. But if I'm in a vacuum and I'm here and my desk is there, I can't possibly affect my desk, right? Not unless there's something in between us that's touching us both. Principle of local action. And by the way, the principle of local action is just like unambiguously true.
Right. There's no special pleading involved.
Yeah, and that gets into a separate conversation, but based on this, logic is able to be consistently applied to physics and science, which it always was. They actually create illogical applications of, well, improper or erroneous applications of logic to science in a lot of the quantum paradigms because they allow for contradictions and stuff like that in logic.
Well, how then? I mean, I was thinking about that, but then they build like what do you call it? An atomic computer or whatever. What do they call that?
Quantum computer.
A quantum computer, and they do use 3 different states.
Never been
that the
proven
matter's
to
in.
actually exist.
But it does
It's just-
work. No, it's been proven to exist.
There's different.
show me.
There's different types of quantum computers. There's only one type that is truly what I would call an actual quantum computer, like true to its name, because they've invented a lot of new like fancy analog computing. Basically, is what they've done. But true quantum computing, as it was originally like named, is computing that's based on quantum state superposition, and there is no quantum state superposition computer.
Exactly.
You know why that'll
about
never happen? You know why that's never going to happen? Because the algorithms are the bottleneck.
Yeah,
As much
that's
as
what
they
they
do with
say.
the hardware, the software is going to brick them.
They can't
It's
write
'cause-
software for it.
It's
That's
because
what
quantum
that's what
state
they say. I've heard
superposition
that.
doesn't exist. There's only wave superposition. You can't have superposition of particles. You can only have superposition of waves, right? So like waves can cross over and add together or subtract from one another, right? 2 waves in the water hit each other and you either make a taller wave or they cancel out. But you can't have two marbles in the same spot. They'll smash into each other and bounce off.
Yeah.
Yep.
So maybe though what they're thinking is like a quantum state. Maybe it is just like the waves we're talking about, but it still works because they figured out how to model something that is not correct, but it matches what is correct.
Well, the
Very
other ones, like I
close.
said, don't use quantum state superposition as the backbone. They use other methodologies for their
It's
process.
still classic, though. It's still classical computing, though. At the end of the day.
Yeah, in order for them to create a quantum state superposition computer, they would have to actually change it from being like driven by like a binary set of data where there's like on off or whatever 1-0, like based on it either it's there or it's not there, and they would have to basically be able to measure amplitude of the wave and say, oh, based on some kind of function, we know that like this amplitude is a superposition amplitude, so we have the third state here based on superposition. But if all they're doing is measuring like an electric field or something like that, then technically they wouldn't know
It's
that it's
just
superposition.
classic.
Yeah, so it's like they would have to just like basically build it into the system and have it be like amplitude dependent as opposed to just on off.
Either
I've
way, it's
watched quite a bit
impossible
about
goal.
I've watched quite a bit about it though. I mean, I've watched several things about them, and they talk about how like what the hard thing to do is to keep it in a in a superposition state.
It's
And
a pipe dream, Cole.
if you're not careful, they said the slightest little vibration can knock it out, and then it
Right.
fails.
That's their excuse for why it
You know,
doesn't work.
Yeah, they say that any external input of energy into the system can cause the wave function to collapse. Now, what's funny is like wave function collapse, right? That's treated as like a phenomenon, but like what in reality, like what they see is there is a collapse in the state of the machine. Like that does happen, and what collapses is they have a wave function that describes the basically the electron cloud. So like Schrodinger's equation, which was turned into which Max Born and his cohort took it and squared it and turned it into a probability amplitude. But Schrodinger's actual equation, the Schrodinger wave equation, describes the full state of properties of a wave. And he said, like because he applied it to electrons, he was using it to model the electron cloud of hydrogen to predict the line spectra emission, the light coming out of a hydrogen nucleus, and he got awarded for it because he worked. But he said that his equation described a real wave in a real medium, like it was like and that the energy of the electron cloud was contained continuously everywhere throughout its trace in the equation, basically. So, like when you see an electron orbital cloud, if you look at like the SPDF orbitals for on like a chemistry chart for an element, for example, those SPD have the teardrop shapes and stuff and the little random different shapes. Anywhere that you see that cloud, it's not that there's an electron somewhere at one point in that cloud. It's that everywhere inside the cloud at any given time, the entire distribution of energy is continuous throughout it. It's
Okay,
like
I got you.
like a
It's
jar of
all
water.
just energy, but it's filled up in that
Yeah,
cloud.
it's filling the whole space, right? It's not
Right.
concentrated at one point. Now, what happens when the detection event occurs is you take your probe and you shove your probe into that teardrop, and now the probe touches a spot on it. And if we
Giving
pause
it its
time,
shape. Yeah.
yeah, if we pause time and then we do like move one frame at a time, what occurs is that needle tip hits it, it cuts into the wave now because an electron is actually a
I
de
didn't think we
Broglie.
actually shoved a needle into it. You're
Well,
talking the needle
I'm just
is
giving an example.
extraordinarily small.
Yeah, I'm just
I thought
giving
we
an
just
example, like a visualization. Any object touches
I
it,
thought we
right?
just tried to. I thought we just measured it some way crazy and something.
I've
Well, you
always
measure an
pronounced that as
interaction. I'm just
Yeah.
modeling the interaction as like
All right,
as
but
if
go
it's
ahead. Go ahead. Keep going.
yeah.
I've always
Sorry,
pronounced
didn't
that
mean to
as the
interrupt
Broglie wavelength. I don't know if
I
you,
don't know how you say it, but I just say de Broglie. But
But
anyways,
isn't it like a
the
fan piezo? So like if
well,
you're
that's a
looking at a,
very like simplified version of it in a 2D
I know, but
topography.
I'm retarded, so I need to like simplify it for my own brain.
Got that
Yeah,
right? No, I'm just kidding.
if you think of it in like a 2D top down view, you can imagine like a
2D
fan
top down view of a
with fan
fan.
blades that are spinning really
Yes.
fast.
You when you measure it, you're basically creating a fan blade a position
No,
in
not
time.
measuring it. No, it's just it is a fan, but the electron is a de Broglie standing wave that's oscillating around the nucleus at retarded speeds, right? And so when an interaction occurs when something touches it, right? So when you touch it, you literally cut into that wave. You like slice into it, right? And the part that's moving towards your finger, say you stick your finger in it, the part that's moving towards your finger keeps going into your finger because you basically just when you cut into it, one side of your finger has the head and the other side of your finger has the tail. Well, the head flows into your finger, and then the tail has to go all the way back around and do a full loop around in order to follow the head and like a snake, like when you play the game Snake, it has to follow
Right.
around.
No, I
and
got
the
what
whole
you're saying.
yeah, and the whole spaghetti noodle unravels and flows into your finger, right? And so that's the wave function collapse.
is it angel hair?
It's interesting. So basically, okay, so
Because when I touch
the
it, it's no longer
one-
stable. I mess with it. I knock it out of a stable configuration when I touch it, and now the energy.
So you're measuring when it gets back into a state. So basically, okay, I'm just trying to wrap my mind around this. So the actual numerical value you're giving, whatever it is that you're, measuring, like in terms of like electron clouds, right? Like you know how there's like different, like valence electrons, etc.
Uh-huh.
Like how it's they show the model as like a concentric circles, or like what would you call that? Like a radius.
Distance
So
from the nucleus.
distance from the
Radius.
nucleus, right?
Yeah,
So
probably
one
radius.
wouldn't just be in a linear direction; it would just be like omnidirectional, like from its center.
Well, yeah, like I gave you a top-down 2D view of a fan blade. In reality, everything's 3D, so it's like a much more complex geometry depending on the element, depending on what energy level you're at. But that suffices to explain the general concept. And another thing is that the actual like oscillation, right? As this thing is moving around, it's harmonic. It only is able to exist in certain stable configurations based on the harmonization, the harmonics in the atom. So that's why you only have certain energy levels that the electron is able to occupy, because it can only create stable standing wave harmonic configurations at certain distances. So the circumference, something really cool that will make this intuitive, make more sense.
It's kind of like frequencies, right? Like kind of cymatic patterns in a sense, where that certain frequency gives its topology, essentially, like you were saying earlier.
Yeah, so something that makes this intuitive is that every electron orbital, if I just imagine it as a big circle around the nucleus in the center, okay, the circumference of that orbital will always be a whole number of wavelengths. Okay. And there's a ratio, there's a whole number ratio between the radius and the circumference. So it's literally
otherwise
building,
it wouldn't be
be stable. It
wouldn't
not
be
able to
stable.
occupy it. Yeah.
Right, so it wouldn't have that radial function. Okay, I get what you're saying. To hold that shape. If it would,
Yeah. So
I kind of get
if
what you're saying.
if the frequency is 30
0.25,
megahertz, 30
okay.
megahertz is like 10 meters or whatever. So if it's a 30 megahertz frequency, the wavelength is 10 meters. Then if it's energy level 1, n equals 1, then the circumference is going to be 10 meters.
Period. Right. If it's 2, 20.
I think if it's 2, I think it's 2 squared. I think you square it. I'm pretty sure. I have to look at the ratio again, but it would be like 4. So it would be 4 of them.
Oh yeah. It would be. Yeah. Yep. Because that's essentially how you do.
And then n equals
the
3, it would
distance
be 9
formula
of them.
over a sphere, right?
There's like an r squared in there, but yeah, it's crazy how intuitive it becomes, and the whole like detection event. That was the thing I was going to say. So a detection event, right? They say that what is quantum state superposition and what is a wave function collapse. So I explained how you stick your finger in it, it breaks it open, and it falls around, and has to come back around and hit your finger, right? But that's the detection. Wherever my finger touched, that's where the electron is said to be. But prior to me touching it, they acknowledge that the electron exists in a superposition. What's that mean? It's everywhere in the cloud all at once. It's
energy dissipation. It's just like the energy is all in the whole cloud is a homogeneous ball of energy. The whole electron cloud.
It's not necessarily homogeneous, because some parts have higher energy density than the other parts do, but it all contains some energy, right? And
but whatever part you disturb, or if it gets disturbed at all,
wherever you touch it, that's where the electron just got detected. That's where it must be. But
that makes much more sense. Instead of it being a full wave, like if you throw a rock in a pond and you see a complete ring of a wave, I picture it as like you could pause those rings in the middle of that pond. If you throw a rock in the pond and you let the waves start heading outwards, and there's always several of them, and they head out towards the edge of the lake or edge of the pond. If you could just pause time for a second and take one of those rings of a wave, one of those ripples, and then cut just a section off of it, like a 2-inch wide piece of it. That's what I feel like that an electron or a particle is. It's not a full wave. It's just like a piece of a wave, but it'll still act like a wave because it is a wave. It's just not a complete wave like we think of. That
it's
like
a standing wave. So
that's a good word for it. It's a standing wave.
That's a hump. That's what you were talking about earlier.
So
right.
A standing wave is created by when you have the overlap of multiple waves, and it create the result of that creates a wave that doesn't move. It just stays in place, and its amplitude moves up and down. And so if you look at the orbital clouds of various elements, right, you'll see that they're all different shapes. And what that ends up coming from is as you get heavier elements. What's a heavier element? It's an element that's more ether in rotation, right? It's a bigger bundle of ether, right? And so as it's rotating, and the electron is the electrons are swirling around, right? New harmonic configurations are created, and the superposition of the electrons swirling around adds up in some places and subtracts in other places, and so some places are filled and some places are canceled, and it just takes on all these new shapes. It's super interesting when you look at the orbital shapes of all the different elements. We've got 100 and something elements; they're all different, and it's super fascinating. You start to realize oh my gosh, the heavier these elements get, the more ether that goes in there, the more it changes what their geometry looks like, because they're having to change their shape of their clouds in order to be stable. And that explains um, unstable atoms like radioactive isotopes, because a radioactive isotope has a little bit different mass than the stable one does. And so that little bit different mass is just enough to throw it out of stability, out of equilibrium. And so you imagine this ether's flowing around. It's like a top that's wobbling, right? Instead of a top that's upright, instead of a gyro that's upright and just spinning, balanced, it's a wobbling top. And a top that wobbles, it'll every time it goes around so much, it'll hit a wobble, and every time it goes around so much, it'll wobble, and another wobble, and eventually it goes crazy and goes out of stability, and that's when you have a decay, right? And so once again, the gyroscope analogy applies very well here, and that works to explain radioactive decay.
Wow. So what are the implications of actually switching it to that kind of a view state, right? Like how does one go about getting the entire scientific community to acknowledge a different fundamental view or perspective of
Well,
how would you go about that?
we got to realize, right? Like if we were having this conversation 100 years ago, plenty of people would agree. It'd make intuitive sense. But the generation of scientists that grew up on classical mechanics and fluid dynamics and would be able to digest this intuitively and make sense of it has long since passed, and all the generations since then have been raised and taught
Yeah.
relativity and the abstraction view through their entire education. So those in order for it to gain traction, you'd have to talk to people who would be willing or able to basically unlatch from their currently held views, and people have that abstraction view are like, well, the math works and it describes the behavior fine, so it must be true. It's like, yeah, but there's no physical explanation there. It's just math with no physicality to it, and they don't care, right? So you have to get people who first you need to train people in philosophy and logic, people who are willing to accept scientific realism, right? Concreteness and realism. And if you operate under the presumption of scientific realism, you know that, okay, an abstraction cannot be an explanation, it can only be a description. So even if I'm describing this accurately, that's not telling me what's actually going on. I need to figure out how and why it's happening. And the only way you can physically do that is if you have a physical mechanism, which the physical medium provides.
Mm. Mm. Yeah, I don't know. I mean, the dogmatic view that NASA show had earlier, like the speed of light is constant, all reference frames are valid, and it's just dogma. Like, how do
That's sort of
you?
what I think he's talking about. Everybody raised on it. It's like
Reference frames aren't valid
they
though.
won't
Like
believe anything different.
all
Yeah.
reference frames aren't valid. When you get on a merry-go-round, a roundabout at a park, and you start spinning super fast, and you see the plane doing like a jumbo jet passenger plane, like a 747 or whatever they're using now. You see one of those planes, and you look up at it and you're spinning super fast and it is doing a friggin' loop-de-loops in the sky. The plane's just spinning in circles. That reference frame is not valid at all because it's physically impossible for the plane to do that in the first place. It would literally tear itself apart. The plane's not built for that. F-22s or whatever aren't built for that shit. Like, you just can't physically fly like that. It's impossible. That is not a valid reference frame at all. Absolutely impossible for that to be valid. That all reference frames are valid thing is just some bullshit they say to try to get out of arguments, and they just
Yeah,
say reference frames.
yeah, only the lab frame is universally valid. But see, here's the problem, Gasticles. Are you still there?
Yeah, I'm here.
Yeah, so you got to also realize, like, not to pick on NASA, like I think that he's probably genuine, but like, here's the problem, right? A lot of these people have philosophical biases that are baked into their like scientific paradigm, and that's we're human, we're subject to that. We can't not be, right? It's very difficult. It takes a very special type of mind to be able to say, look, I'm going to completely separate my science from my philosophy and be philosophy agnostic in my science. That's not an easy thing to do. Most people can never do it. Like legit 90 something percent of the population, 90, probably like 98%, maybe not that, but like a very large number, right? And when you say things like, okay, well, I can show you this proof or this evidence or this experiment that demonstrates the invalidity, the non-validity of your mainstream model, right? It's not that like it's impossible for anyone to show evidence to the contrary, right? Because like that's how science works. Things have to be falsifiable. You have to be willing to look at new evidence. Like that's literally the backbone of science. But people become unwilling to do that because they're afraid of like what would be the philosophical implications if I were to give up this paradigm, right? For everyday
Do you think
people
it's a
walking,
philosophical fear more
yeah,
so being wrong in the scientific community? Because it's more about like them being wrong in their idea of what this place is and how it works, and if it works this way, then that means that Earth does occupy a special place. There are consequences to my actions.
yeah,
I am accountable if there
yeah,
is a
dude.
creator.
The anti-God people will always be the most staunch opponents of anything anti-mainstream because their worldview and their identity is tied to their philosophy. And if you take that away from them, they're like completely lost, right?
And what is the mainstream worldview right now?
The mainstream
It's
worldview within
secular.
academia and science is
Yeah,
secularism, right? There
exactly.
is,
Yeah.
we can explain everything in the universe without needing God at all. We can invent, 16 billion years ago, an explosion of nothing created everything, and blah 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 blah, and on we go, right? So if if someone is already fully bought into that and they know where you're going with what you're trying to explain, right? If they know where it's leading them, they're going to immediately be opposed to it. Sometimes, if you
Incessantly
find
interrupt you, call you a liar,
right,
ad hom
because
you.
they're already negatively reacting to even the idea of things being wrong, right? They don't even want to allow you to speak or levy your your evidence or your experiments or whatever. They don't even want you to be able to say it because they like that would cause the conversation to progress and their brain to form conclusions about it. And I don't think they do this consciously, most of them. I think it's just like the way that the human brain works when you're into this like matrix delusion, right? Like they've been deluded by falsehood, and that's one of the natural consequences of that.
Mm.
So to answer,
Real
like, if it to full circle to tie back to your original question, I think that the way that you do it is you just continue to have these patient conversations with everyone that you're able to get to listen, and then you also just lay down just this cold, hard, raw science and logic, and campaign for it, and then you just let the cards fall where they may, and you pray about it. Because ultimately, you can lead a horse to water, but you can't force it to drink, right?
No, yeah, for sure. By the way, this is what Lion just tagged me in to try and help explain. I was just listening to it for a little bit, but to try and explain what you were talking about in terms of like when you take a slice of that electron cloud.
Yeah.
Yeah, this seems to be related.
Jesus, just for funsies, if you've never heard the logical binary question list that Witsit came up with, you should just click on those pictures and read them. Like read them
Tag
out
me in
and
it.
read. I didn't tag you. I put it on. I just put it in
I
the
know,
chat
but there's
around
so
8.
much. There's so
Can you
much.
control
8:42.
F? Can you control F and like search the chat and find it, and then
Yeah,
reply to it
it's
and
at
tag them in the reply?
8:42. Yeah, but yeah,
I'm
it's
watching your
just binary
video.
questions, and it goes to a logical conclusion. That's hilarious.
8:42.
Can you keep playing this video? I'm very interested in what this guy has to say.
Okay.
Take the proton, and you take all the modes of oscillation of the 0 point in it. Okay? And you calculate how many modes of oscillation all the way down to the Planck size, to the smallest, inside the oscillator, right? Because now you didn't remove the source of oscillation of the oscillator.
Yeah,
You have
changed
it
the
in,
whole, yeah.
yeah. So now you have it in there. So you calculate,
Yeah.
and you imagine the waves are bouncing all around, and some of them are canceling out, and some of them are building up energy, right? And so we calculated that. It's called the correlation functions equation. And when we calculated the amount that are canceling out, most of them are canceling out, but some of them are building energy, and we got the exact mass of the proton. Exact mass we measure, right? Which is remarkable.
Yeah.
And the next paper, actually, we show that the ratio of the ones that are canceling out to the ones that are building up, that are creating energy, that ratio is very, very special. But I'm going to keep it for the paper. Okay, it's very, very special. But basically, it gives the correct answer.
Yeah.
And then we calculated how much pressure it would produce inside the proton,
Sure.
this energy.
Yeah.
And we got the pressure that they're measuring that's inside the proton, which is similar to the pressure of a neutron star. It's like really high pressure. And it's called the color force. It's the force that is at the source of like the confinement of the protons together in the nuclei. And we got the right answer. So we have the Planck force, then it gives the color force in the proton, then it as you get away from the proton, it drops again, and it gives the residual strong force, which is the nuclear force that holds the nuclei together. And then you keep going further from the proton, and approximately 2.6 protons away, it becomes the gravitational force. So we showed that it's all the same force. What Einstein called space-time is just the fluid dynamics of the 0 point energy. You take the proton, and you take all the modes of oscillation.
Yo. Yo. Wow.
Yeah, dude. When did this drop, bro? Can you give me the
Dude,
screenshot of
ask
that paper?
Lion. Yeah, I did. I sent it to you.
Holy frick, dude.
If that wasn't the exact thing you were just talking about, I don't know. Like, Lion, I'm gonna put my vote on it. Lion is the king of relevance this year. 2026, Lion as the king of relevance.
I appreciate it. No, I mean the thing is, dude, people have been talking about this low key for a while now. I know like Lockheed Martin, they got technology beyond your wildest dreams, and they understand that. I think like
I think that's why they keep it hidden. Remember how
yeah,
Cole
they
asked,
keep it hidden,
like,
bro, for national security reasons. They don't want
yeah,
other countries knowing what's actually going on. Let them keep believing the Einstein relativity is all. You know what I mean? Like I feel like this stuff's already been leaked long ago. It's just slowly reaching. It's boiling up.
Well, the private sector, not private sector. I mean, the like academia, the public sector is like slowly catching up to what these like
Yeah.
super dope like development labs, like private government
These
contractor development labs
engineers.
have already known
Yeah.
about. Because I'm sure they already figured this stuff out probably a while ago, but it's classified, right? Like all these equations that they figured out are
Right. Right.
classified, and you don't learn about it in a university class, right? You can't go take a course on it. But if you're in the Skunk Works or whatever, like black team of development somewhere, I'm sure those guys probably knew about it.
Do you think they figured out the ratio for?
Dude.
Okay, all right. Check this out. This is where I'm going with this. We remember how we kept talking about it. How do they keep those satellites up there? Because there's things up there.
Uh-huh.
What if they
Yeah,
figured out that ratio?
Well, yeah, I mean, the first satellite was launched up in 1949, or was it 50 something? Hold on. When was Sputnik in it? 52? Hold on.
No, earlier. Wasn't it? Wasn't it like
I
40?
should know this, and I don't.
No. It was 1957. Yeah. Okay, sorry.
57.
1950. Yeah, 57. And then 3 months later we sent one up in early 58. October 57 was Sputnik, and then ours was like 3 months later, January 58.
Dude,
Or
Sputnik only orbited for 92 days before burning up.
Yeah, it's really
yeah.
low.
So
That's wild. Okay, so 92
but if you look at a
days.
picture of Sputnik, right? So you've got this big metal sphere, which you can't see inside. You don't know what is in it, and then you have these like antenna rod things sticking out of it, which if they're whatever's inside of it is imparting charge or something to the outside. Who knows what's going on? But I'm sure that whatever they're doing, right? They figured out what the fluid dynamics equations are in order to keep those things up there. Whether it's some kind of like just macro scale, like Newtonian type mechanical force, or whether there's like some kind of like electrostatic coupling that's going on. I don't know, right? I would get paid a lot of money if I did know, I'm sure, but I don't know. So, but yeah, dude, it's all very interesting.
Dude,
It's
okay,
also
so
interesting the timeline, right? Because if you look at the timeline of like the Antarctic expeditions and the space program and the first satellite, as well as like ionic thrust engines and stuff like that, they all happened right along that timeline.
I know, dude. And you know what happened afterwards? Like right afterwards, you had like the high altitude.
Explosion, detonation.
Yep, and also the artificial ionosphere tests by using tiny little copper dipoles to create like an artificial ionosphere that they could bounce signal off.
Yeah.
You heard about that Project Westford? Look, dude,
not sure.
look up. Here, I'll just give you the Wikipedia. All right,
Dude, but it's so crazy. This guy's like, yeah, Einstein space-time stuff was really just fluid dynamics. I'm like, bruh, that's what I'm saying, dude.
that's literally what you said. You're like, dude, it's crazy how fluid dynamics could be the explanation to everything, and this guy just says it.
He's like, yeah, we just predicted the mass of a proton, the strong nuclear force, the color force, radiation pressure, and all this other stuff using fluid dynamics and adding up all the oscillation components and the correlation function for them.
Bro, do you see Project Westford? The picture right there is to show the scale of one of those copper dipoles.
Project
Do you see how?
Oh, tiny little copper strands, like hairs,
Literally.
almost copper hairs. Yeah,
Yeah.
and when they shot those up in the air, that created like a mesh in the sky of like,
Yeah.
wow.
Yep. I'll show you the other paper. So.
Wait, is that stuff still up there?
No. No, definitely not. But when
They spray chemicals out now, so
hold on, let me see. Project. Here we go. So there's 2 of them. So there's one that says they are still in orbit. By the way,
okay, yeah, they're still up there. Yeah,
they call it the
probably.
X-band transmission. So
Oh, that's
yeah,
X-band.
yeah, dog, yeah.
What?
Okay, all right. So I've been looking into this ever since I came into this subject because I used to work for Dish Network. So I was always curious. I'm like, okay, so what the fuck are they aiming at actually? And that's what they're aiming at, dude. I think they created their own little artificial ionosphere as well, using the same kind of principles. They just call them EcoStar, right? EcoStar satellites. But when you actually look at an EcoStar position, like if I go to EcoStar 9, for example, I'll show you like what it looks like in images, right? Check this shit out.
Put it in the chat. Oh, Echo. Yeah, let's see. Transmit and receive.
Yeah.
Receive.
So what they say is that those 4 channels are like 4 channels coming down from a satellite, right? Where it's line of sight, but just picture it as like the opposite. Where it's not beaming down, it's beaming up. Those are transmitting. Like they just basically created these like areas where I think they
Wait, are
just
you
launched.
saying that your antenna is not pointing at a satellite? It's pointing at a layer in the atmosphere of copper dipoles?
Yeah, that's my theory.
Oh my gosh.
And the reason why is because you would just like imagine they just launched so many of them, right? Some of them would deorbit, some of them would just get launched into space or whatever. Like, but some of them would hit a neutral state and just stay up there,
Yeah. Well,
just
you
like
know.
geostationary satellites.
Yeah, I mean, we have satellites up there. Like,
Okay, but that's what I'm saying. Like,
no, like
I
you
don't
can
think.
see the ISS go past you at 7 bajillion miles an hour. Like you can watch it.
Yeah, that's a little different. A little different than what I'm saying. Because what I'm talking about is broadcast transmission, not
Yeah.
just not like like no one uses the ISS to get their their fucking sports game. That's not
Yeah.
what I'm talking. What I'm saying is like
Yeah.
in terms
Okay.
of
Okay.
broadcast and transmission, in terms of like radio signals.
You're saying instead of like saying that some satellite up there has the bandwidth to transmit this station out everywhere, that maybe they're just beaming it up from the ground and it's like bouncing off and radiating out everywhere.
Hence why you have to have a line of sight.